I mean, it's not a big deal. I'll get it back. I can handle one low scoring test.
You missed force. Would you get like an 89?
I think it was like an 81 or something like that. It was a low B.
Okay, fair enough. Fair enough. Are you sure? Anyways, are you sure those are the ones that you missed?
Yeah. I mean, I almost 4 out of the 32.
Well, like a lot of the questions are with like 0.3, 0.2.
Oh, that's true.
Yeah, so I would check with them and just have them go over the test with you and see what happened.
Yeah.
It's not for your contract, just to make sure that's actually what happened.
Yeah.
And he'll want to be on it. And he's really good about it, to be honest. He's really good about like scheduling a time that works for you and working through it.
All right, you guys have the quiz up?
Yeah, I have a quiz. I'll take question 3 if you guys are okay with that.
I'm ready.
Yeah, that's our general order. Yeah, let's do it.
Which hypothesis involves equality? The null hypothesis.
Correct.
Number 4. Remember that the p-value is the probability of obtaining a sample statistic that is extreme as the one that is actually observed. When computing the p-value, which hypothesis do you assume to be true? The null hypothesis.
Right.
The null hypothesis mean equals 10. Which is the alternative hypothesis for two-tailed tests? C. Mean does not equal 10.
Yep. Okay. Get back to me, right? Where's it?
It's Mac.
Sorry.
Which of the following represents the alternative hypothesis for a left-tailed, and a left is going to be less than? So it's A.
Like these questions.
I know,
right?
I'll take that. Okay. Which of the following represents? Oh, yes, them. We love them so much. Is that B?
Yep.
Greater than, right?
Yep. I make my life so easy. I think the test questions should be like these ones.
8, I'm going to need help on, because I don't understand this whole, what is that symbol, alpha? Remember that we determined the outcome of a hypothesis test by comparing the p-value to the level of significance for alpha. Is that correct?
Yeah.
Yep.
Alpha is a symbol for level of significance. And so in the reading, Becky, we read that if alpha is greater than if alpha is greater, if p-value is greater than alpha, we fail to reject the null hypothesis. If p-value is less than alpha, then we reject the null hypothesis.
Is that's the if the p is low, reject the null.
Yep.
Yeah,
Yep.
yeah. And the alpha is just the cutoff point that you decide on.
Yeah.
Okay. Okay.
So that's B, right?
A.
Right.
A.
It is A. We're failing to reject it.
Oh, failing to reject. Oh, I missed that important word.
Those stinking double negatives.
I turned it around. This in my account class. It's like I don't know which way I'm going. Positives and debits and credits and reject and fail to reject.
It's like
Yeah.
Okay, so number 9, p-value is less than A or alpha to reject the null hypothesis.
Yeah.
So B.
All right, number 10. I think that's me, right?
Yep.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be appropriate alternative hypotheses? It would be C, the average claim is greater than $1,500.
That is correct.
And you wanted to Disneyland. Okay. Sorry, I thought it was funny. Okay. Which of the following would be appropriate null hypothesis? The average claim amount is equal to 1,500.
Mm-hmm.
So A.
Yep.
Okay, with our information here, the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? And I say it is a good assumption since the sample size is large.
Yep.
Yes. All right. What theorem or law justifies the answer to the previous question? That's the central limit theorem.
Yep.
Mm-hmm.
I think it's a law of total probability, guys. Sorry. Sometimes I really think. I really think I'm funny. And I'm not really.
Which of the following is the test? Oh, sorry. 14. Which of the following is the test statistic as defined in this lesson? It is Z.
Well done.
So somebody
Mine and the
explain
Z-score.
that to me real quick. I missed that. Test statistic. So that's not the Z-score anymore.
No,
It
it's
is the
still
Z-score.
Okay.
It is the Z-score.
It's just kind of another term for Z-score is test statistic.
They're
Okay.
just doing it to make us. Don't worry about it.
Okay. Okay.
They're just trying to do what they can to confuse the heck out of it all. Okay. My turn?
Yeah.
Or is it- Okay.
Yeah.
The historical mean of sales receipts at a grocery store is 150 with the standard deviation of 40. I have a suspicion we're actually going to be doing some math in a second. The store manager
not writing
suspects
this
the average cost is decreased. He used the hypothesis test with the hypothesis. Blah blah blah. So we can nice look at it. She'll use significance of 0.5. She then takes a sample random and computes the 144. So that's 144. Here's your first answering the next 4 questions. What is the Z-score associated with the test? So that is our beloved 144 minus 150 all over. How many samples did you take? What was that?
36.
36. Thank you. I somehow missed that. So that is our 40 divided by 6 as well. Okay.
I got negative 0.9.
That's what I got as well.
So that's just that extended equation. Z equals x bar minus mu over standard deviation divided by square root of n.
Yes, ma'am. That's our favorite equation.
Yeah.
3 decimal places, so negative 0.900.
Oh.
Or you can put just 0.9, I think. You know, let's put 0, 0 in for kicks and giggles.
Why not?
Yeah. Okay.
Okay, so then to find the p-value, we are going to go to the probability applet.
All right. Think of it like Walmart. It's an outlet.
And we will put in for the z-score 0.99.
Ne-
Not 0.900. And then,
It's less.
what's that?
Keep going. I was about to jump in, but I don't need to jump in.
That's okay. And so then it's 0.6319.
No.
We
Oh,
did
I got 0.184.
Yeah, that's what I got too. So it's left-tailed, Becky.
Okay.
So
The point. So we've got the left highlighted and the middle highlighted, or just
No.
the left?
No, what? It's one tail.
yeah, it's left of the z-score. So whatever's left of the z-score. So if our answer was positive 0.9, it would be both of those. But because it's negative 0.9, it's only left of that z-score. Does that make sense?
Okay. Yep. So
And if it was not equals, then it would be the far left and the far right side.
Yes. Because it's left tail. You're doing it good. Okay.
Thanks. So 0.184.
Yes.
Okay, let's see here. What inference can you make about the null hypothesis for this problem? So the alpha was 0.05, which is p-score. So we are going to fail to reject the null hypothesis.
Yes.
Correct.
Well done. Failed to.
Okay.
What is your conclusion for this problem? We have sufficient evidence that the true population mean. Let's see here. Yeah, we have sufficient evidence that the true population mean is 150.
So because we can never prove an actual population mean, it can never actually be completely thought of as true, but we have sufficient evidence that the true population mean is, wait.
Oh, so we have insufficient evidence that the true population mean is less than 150?
Yes.
Okay.
Oh yeah, because it's always referred back to the alternative, isn't it?
It's
Yeah.
so stupid.
It's the most complicated thing in the world.
Yep. Sorry, it is. It's C there.
Okay.
But we did not prove that it's less than 150.
We just proved that it's not less than. Okay. Yeah, they're just, sometimes they really just want to screw with us. That's really my opinion. Like, is this next one mine or is this one? Mac and Mark, you guys sound a lot alike. Whose is it?
It's yours. You're up.
Okay, sorry. You guys just sound a lot alike, and so I'm like, wait a minute, who just got done? Okay. So type 1 error.
I'll start talking like this.
Reject the So type 1 error. Well, reject no process when it's true. So type 1 error.
Oh.
Yep.
Okay. Oy, oy. Funny. I thought we were done. Okay. Right. A researcher decided that instead of using a level 1 significance of alpha 0.05, we will use alpha 0.01, which is the following is true. Probability of a type 1 error increase. I have no idea.
Okay, so
Not me.
no, it's not C and it's not E. So if a type 1, so the lower the alpha, the less likely a type 1 error will increase. Less likely a type 1 error will happen. It's less and less likely. So it would actually decrease the probability of a type 1 error. However, the more you decrease the probability of a type 1 error, the more you increase the probability of a type 2 error, which is finding a fault, not failing to reject a null hypothesis. So it's the second one.
Okay.
Does that make sense, guys?
Yep.
It's Becky. Does that make sense?
Yeah.
Is that really a yeah, or is that yeah?
Yeah, that's a yeah. That's a like. I'm gonna have to write it down. I'm a very I have to write it down and think through it. So that's good for me for now. I'm good.
No worries.
Thank you. So that was my turn that Sarah did for me.
Sorry, guys.
So on to Mark.
Let's see here. Compute the probability of committing a type 1 error. Well, it's just 0.05, isn't it?
Yeah. of the round to 2 decimal places. They're so funny. Oh, everyone hit submit squiz. Submit your squiz, please.
Quiz it.
Here's everything being right. 100%. Well done, team.
Woot.
All right,
Hurrah!
guys. Hey, Mark, did you make it to your appointment last week?
Yeah, I was just a little bit late, but it was all right.
Okay.
For it to matter.
All righty. That was awesome. Good job, guys.
I appreciate you guys.
You guys are amazing.
I
Thank you.
appreciate your contributions to the team. A valued member of the group.
All right, we'll talk to you
Same
guys
time
soon.
Monday, or Mark, do we need to go earlier again?
Oh, we're good.
Okay.
But that was a one-off. I'll let you guys know when I need to change my schedule for work.
Okay.
But that'll probably be like the last 5 or 6 weeks of the class.
Okay. We'll make that work.
Sounds
right.
good. Thanks.
All right, thanks guys.
See you guys.
Have a good one.
Bye.